So now let's talk about joins in the SQLite world, right? This is the real power of a relational database. And basically the idea with joins is that in a relational database, each table should be used to store a specific type of record. So if we go to the example of parts and vendors, you will have one table and that will just be for parts. The name of the part, the description of the part, maybe the price of the part, that type of thing. And then you will have a vendors table, and what the vendors table will be is the company name of the vendor, the address, the phone number, maybe the terms of payments or whatever with the vendor, and those are two different tables. And then what you're able to do with joins is in a SQL statement, you're able to join those two tables together so that when the results print out, you can get information from both tables seamlessly within that one result. So you get the name of the part, the price of the part, and the vendor for the part with the email address of the vendor, and you get that all back as one result. So we talked about the basic concept of relational databases quite a few classes ago at this point, but I want to go over it again. And now that you understand the concept of things like row IDs, now you're going to start to get what I was talking about before with needing things like absolute unique identifiers when you start making these more complicated database backends for whatever application that you're trying to create. So let's say we are creating a schema and we come up with a parts table here, right? So with the parts table, you're going to have this, and basically the columns are the different values that are supposed to go in here, and so you may have a name for the part, and you may have a description for the part, and you may have a price for the part, but one of the things you might have in this column is a vendor ID number for the part, right? So you have name, description, price, and then the vendor ID. Then over here, you can create a vendor table, right? And in the vendor table, what you can have here is you can have these different columns, and the columns will be the vendor ID, then you'll have the name for the vendor, then you have, the URL for the vendor and terms and all of that kind of thing, right? And so basically here we'll have multiple vendors, 2, 3, 4, 5, 6, right? These are the different records. And over here we can have records for parts, name, description, blah, and then this goes to vendor 1. Name, description, price, this goes to vendor 3. Name, description, price, this goes also to vendor 1. Name, description, price, and maybe this goes to vendor 4 right here, right? And so the idea with the join is so you have this vendor ID here and you have this ID here. And so when you do something like a select statement, you're able to join these two tables together based off of that particular column value, right? And again here, right, we have this part here and I can connect based off of that column value. So again, if I get the results back for this part, it will take the information from the parts table and from the vendor table, and I can get a result back that I can do something with. Now, again, at this point, we've talked about primary keys in the past, and we've talked about row IDs. Maybe it starts to make sense why row IDs can be a little scary when you start creating more complicated, database type structures. So we have this ID here, and this is called a primary key. So when we create this particular table, we create an auto-incrementing integer primary key. So what does that mean? The primary key says that this has to be absolute unique. So every record in this table, this primary key has to be a unique value. It cannot be shared by any other record. It's an integer, so it's a number, 1, 2, 3, 4, 5, 565, that type of thing, and it auto increments. Every time you create a new record, basically it increments up by 1. The good thing about the primary key here is that if I delete a record, it just basically keeps going up in numbers from wherever it previously stopped at, so I don't have to worry about this number ever being used again, right? So let's say in some query or something that I have, I'm pointing to a primary key, or I'm pointing to a vendor with a particular primary key, that vendor gets deleted. I don't have to worry about a soft fail where I get an answer but not the right one, right? So even if the query completely fails, I know there's a problem, and I can go back and try to figure out what the hell the problem is. Again, a good hard fail. There's nothing better as a technology professional than a hard fail, because you know something's broken. But again, I've talked about these tables before. One of the cool things, one of the valuable functions of SQLite is they add a row for you called row ID, right? There's a row ID, and that is an auto-incrementing integer, right, value. So every time you create a new record, it goes up by 1. The issue is, and especially when you're doing joins, why you probably do not want to join based off of a row ID, is if you delete a record, right? So I delete record 2. The issue is with row ID, with SQLite, it may decide at some point, oh, I'm just going to reuse value 2 again since it's not being used, right? The important thing is you can't use the same value at the exact same time. But if you delete a record, that value is no longer being used, so it's open for SQLite to use again, and it might use it down here in a different record. And so basically, if I have something that points to 2, originally it was pointing here. This gets deleted, right? Or 2, this gets deleted, and then all of a sudden, it's now connecting down here, and you're getting entirely different vendor information, which can be an absolute disaster. So this right here is why it's important to have that primary key, and why the row IDs can be dangerous with joins. And again, just a reminder of basically how these joins work. Now, if you know anything about relational databases and you're watching this for some reason because you're just bored, one of the important things to understand with SQLite is it only allows for inner joins and left joins. So I'll talk about that a little bit later in this particular class. In other database systems, again, MySQL, MariaDB, Postgres, that type of thing, there are a number of different joins that they allow you to do. So the important thing to understand with SQLite is that they simply allow you to do inner joins and left joins, and that's basically it. There's a way to duct tape stuff together, but if you're duct taping stuff together, use one of those other database systems. This is one of the prime examples, though, of when you're choosing whatever database system that you're going to be using for your projects. You do have to understand a bit about them and do some research just to verify that the database system is going to do what you want to do. Again, SQL, structured query language, should be basically the same amongst all these relational database systems, but sometimes their functionality isn't quite the same. The same is true with something called foreign keys. Again, if you don't know what a foreign key is, don't worry about it. We're not going to go over it in this entire thing. If you do know what a foreign key is, basically, again, all this is where you're able to connect the two tables. You're able to join them based off of a value in a particular table. And what the foreign key does is it basically makes it so that foreign key can't be modified, can't be edited, so you can't run into some weird problems. The issue thing is with SQLite is that foreign keys are actually disabled by default. But here's the funny thing about SQLite. When you create a foreign key, it won't tell you that. So when you create a table, so there's the steps for creating a table. So when you create the table, one of the things you can do at the end is you can assign foreign keys. So the foreign keys for these other tables, this is what they are. So you can assign the foreign key, right? And it goes through. Looks like you're doing good. And then when you go to test it to verify the foreign key system is working how it's supposed to work, it doesn't. It doesn't. And the reason is because that functionality is just off by default. So foreign keys, don't worry about it a lot with SQLite. You can turn them on. If you know what a foreign key is, you can turn them on. What I decided to do is we're basically doing an introduction to SQL series with this, with SQLite. And so I'll probably talk about foreign keys later. Maybe when we go to MySQL or Postgres, we'll do a series on that and basically add some of the additional more advanced SQL functionality in those particular classes. So again, that's just a long-winded way to say, don't worry about foreign keys. So before we get into the joins, let me show you the lab environment I created in order to actually be able to do the joins. I'm going to show you here, just using the web page, so you don't have to worry about me fat fingering through this whole process. So here in SQLite, I just simply did the period schema. So that's the command to show basically all the tables that have been created and how they've been created. So I created a table. So create table part. has a name, has a description, and has a vendor ID, and I close with a semicolon. Then I'm going to do create table vendor, and here what I'm going to do is I'm going to do vendor ID. See, that's what's going to match. That's what we're going to be joined off of. It's going to be an integer, because you have to assign that for a primary key. We're going to call it primary key. There's a space there, so it's a primary key, so this has to be absolutely unique, and it's going to get auto-incremented. So it's an integer that gets auto-incremented, starts at 1, keeps counting up, and then we're simply also going to have a name. Again, you could have 50 columns here. I'm keeping it simple. I then added values to the part table and to the vendor table. So we have name, description, vendor ID. So select all from part. Widget, a thingy, goes to vendor ID 3. Sprocket, another thingy, vendor ID 2. Ratchet goes to vendor ID 1. Washer, vendor ID 2. And doodad is another thingy, but it doesn't go to any vendor ID. And this is something that I want to show you with these joins. So I'm going to show you how to do an inner join and a left join, and I'm going to show you why you have to be careful with how you do the joins, or you might run into some weird problems. Then down here, again, we do a select all from vendor. So we have vendor ID and name. Vendor ID is 1, cool company, 2, better company, and 3, amazeballs. So at this point, you should be able to create these tables and add your own records to these tables so that you can start playing around with these joins. So now let's talk about inner joins. So what an inner join is going to do is if you basically, again, you have that vendor ID on the part record, and you have the vendor ID in the vendor record. Basically, any time those actually match up, that will get printed out onto the screen. So you have vendor ID here, and it matches a vendor ID in the vendor table, then the records will print out on the screen. The important thing to realize, though, is that if they don't match, if there's not a match for some reason, basically the record, again, the part at this example, will not show up at all. You'll only see the records where there is actually a match. So with the inner join, what you do is you do select all from table 1, so the first table that you're joining on. You say inner join table 2 on table 1 dot column, right? So it would be part dot vendor ID equals table 2 dot column. So it would be vendor.vendor ID, and that is how we're going to be joining them together. If we look here, this is the actual example. Select all from part, inner join vendor on part.vendor ID equals vendor.vendor ID. Right? If we take a look here, so name, description, vendor ID name. So widget, a thingy, 3, so that is where you joined. Amazeballs. Sprocket, another thingy, 2, better company. Ratchet, another thingy, 1, cool company. Washer, another thingy, 2, better company. But, again, if we go up here and we take a look at the records we created, there's a doodad. What happened to our doodad? What happened to our doodad is we do not have a vendor ID value there, so there was nothing to join on for this inner join, and so now we don't have any value for doodad showing up. And this is what I'm telling you can be something like a soft fail. If you're trying to print out all the parts with all the vendor information, and for some reason a few of your parts don't have that vendor information, if you do a inner join, those parts will not show up in the report, and then, fun can ensue, as they say. So this is the idea with inner joins, and basically you just have this inner join here, table 2, so table 1, inner join on table 2, on table 1 dot column equals table 2 dot column, and this is the results that you get. Now, if you're sitting there and thinking, ooh, inner join is probably a crap idea. Like you can already envision the disaster of an inner join. That's why we've got a left join. So basically what the left join does is it'll print out everything on the left-hand table. So we talk about left table, so it's that first table we're referencing. All the records there will get printed out, and wherever anything matches in the other table, that will also get printed out. So again, that's what I'm talking about with other database systems. There's something called a right join, and what a right join does is it'll print out everything on the right side table and only print what matches on the left when it matches, right? But anyways, so this is left. Whatever table we reference first, all of those records will get printed out, and then for the second table, only the records that actually match with the first table will get printed out. So select all from table 1. All it is left join table 2 on table 1 dot column equals table 2 dot column. If we take a look at it here, select all from part, left join vendor on part.vendor_id equals vendor.vendor_id. Again, name, description, vendor ID name. And so widget, a thingy, 3 amazeballs. Sprocket, another thingy, 2 better company. Ratchet, 1 cool company. Washer, 2 better company. Doodad, there's nothing there, but it still gets printed out. So again, with whatever system that you've created, you can get to the report and go, oh, somebody forgot to plug in the vendor information for the doodad. I need to do that now. So this is what we're talking about when we're talking about joins. So as with everything that I'm going to be teaching you in technology, joins are simple, but getting your brain around joins might be a little bit of agony. But, you know, that's the field that you're getting into, right? Once you understand how joins work, you'll be able to do them, you know, lickety-split, but sometimes it'll be a little bit hard to get your brain around the concept. The big thing, though, that I want you to be thinking about, and one of the things I've talked about a lot in this series of classes, is the value of whiteboards, right? As I've said many times, 90%, 95%, 99% of the work that technology professionals do, and where we get paid for it, is actually going to be done on the whiteboard. Very little of what we really get paid for is writing out the SQL and doing the code and that type of thing. And when you start looking at these joins, I think it starts to make a little bit more sense about why I'm saying that, right? So you have to be thinking about this. This is simply parts and vendors. And so you've got to figure out the tables that you want, then you have to figure out the schema, the columns for the tables, then you have to think about how you're actually going to be doing joins on the tables. And this is 2 tables. This is 2 tables. Imagine if you actually start building a much larger system where you might have 20 or 30 different tables, and in a finished product, you have to be able to join those tables together properly for each individual query, make sure data is being saved, the records are being saved properly, stuff doesn't get corrupted, and all of that kind of thing, right? That's why I say these whiteboards are so important, and when you sit down to design your application, especially if you're going to have a database system on the back end, you really have to spend a lot of time thinking about what this is going to look like before you start writing your first line of SQL or Python or anything else. But that's basically all there is to joins. And again, this is the power of what a relational database can do for you. It is incredibly useful, but again, your brain might hurt for a little while as you try to get your mind around it.